Okay, for station number 1, text structures, we're going to be practicing and focusing on text structures. The first thing we're going to do is read this passage. So remember, think about the structure of this passage as I read. Also, for some reading practice, follow along either in your heads as I read or read out loud for some fluency practice. Okay, A Screamingly Good Science Lesson by Elizabeth Keebler. Amusement park rides gives us thrills, exhilaration, and delight. If you pay attention, these rides can give you something else, a science lesson. Roller coasters are amazing rides that can twist and veer until you scream. However, these rides can also help to show us how types of energy work. Think about the first part of a roller coaster ride. A machine slowly pulls the cart higher and higher on a hill on the track. As the cart gets higher, it gains potential energy. Objects gain potential energy by being lifted farther from the ground. Potential energy is stored energy. The higher an object is from the ground, the more potential energy it has. When the cart reaches the top of the first hill, not only are riders' stomachs screaming for mercy, but also the cart is at its maximum potential energy. Without warning, the energy-loaded cart begins to descend the first hill. As the cart careens down the hill, it has kinetic energy. Kinetic energy is different from potential energy. Kinetic energy is the energy of motion. All objects in motion have this energy. The kinetic energy propels that cart down the hill. Eventually, the cart will fight the forces of gravity and travel up another hill. On this uphill journey, the cart again begins to gain potential energy. The cart switched from potential energy to kinetic energy and back again. Therefore, a roller coaster ride is just the converting of kinetic energy and potential energy. After the first collection of potential energy, the cart does not use ropes, pulleys, or an engine. The cart, its wheels, and the laws of science are the only things that keep carts rolling firmly down the track. The air brakes on modern roller coasters bring the cart to a safe and smooth stop. If, however, a roller coaster has no brakes, it would ultimately stop on its own. The friction between the wheels and track and the friction between the cart and the air would eventually make a coaster stop. Think about a super ball. Although it gains potential energy every time it goes up, it eventually stops bouncing. In much the same way, the roller coaster cart could cease to move. Today, amusement park owners continuously try to outdo each other with bigger and better coasters. They believe that the more screaming their patrons do, the better the ride. Although the new rides of the day are going beyond what many thought was possible, it is all a matter of science. So, the next time you find yourself about to plunge down a gigantic roller coaster hill, try to think about the science of the amazing ride. Or, if you can't stomach that much thought, just hold on and enjoy the ride. All right, so after looking and reading at this article, I can tell that this is all about science and roller coasters. Just by looking at the title, looking at the picture, picking out the key words, I can almost predict that before I even read that this was going to be all about science and how roller coaster works in the scope of science. Okay, so we are talking about text structures, and inevitably, we want to figure out what text structure this is. But before we do, let's look at all the different kinds of text structures we have. We have 5 different text structures. There's description. This is when you're looking for something that's talking about characteristics of something using signal words like such as, for instance, in addition, specifically. To find out if this is description, ask yourself, what specific person, place, or thing is being described? In that roller coaster passage, although we have a lot of description, I don't know if it's completely descriptive. I'm not sure if they're being extremely descriptive or not. But let's look at our other text structures to figure out. Problem and solution. This is whenever you have an issue and then you have a solution to solve it. Right? Be careful with cause and effect and problem solution. They're very similar, but the biggest difference is this word here, solution. Okay? So remember, ask yourself, what is the problem? What is the solution? I don't know if this is problem or solution because they're not talking about a problem or a solution. There's not saying roller coasters are the worst things in the world, this needs to stop, and this is how we're going to stop it. That would be problem solution. But because we're not really talking about a problem or a solution, I'm going to say no to that. Then we have compare and contrast. This is when you're comparing two or more things. You're looking at the similarities or the comparisons and the differences or the contrasts, right? So you ask yourself, what's being compared? Looking here, I don't think we're comparing anything. It's not like we're comparing roller coasters to science. We're looking at roller coasters in the view of science. So there's not really compare or contrast. If there were, you would see words like favorite, less, more than, least, other. On the other hand, differences, similarities, I don't see those here. Then we have cause and effect. Cause and effect is whenever you have a relationship of two things, right? You might have a cause, something that happened, and then effect because of that cause. For example, I love the example of dominoes. You have a stack of dominoes, you flick it, all the dominoes fall over. The flicking of the finger is your cause, all the dominoes falling over is your effect, okay? Looking here, we might have a cause and effect passage. If you think about it, we're talking about roller coasters, what the relationship between roller coasters and science is. So exactly what the cause is of the machine slowly pulling the carts higher and what the effects can be. And they go into detail with these paragraphs here. And then you have sequence. Sequence are things like directions, tutorials, steps. This is basically asking when things are going to be completed. You have to ask yourself, is this event taking place over time? And remember, sequence has all different types, right? Like chronological, things that have like a timeline, right? Things are going in a sequence. You also have order of importance. That's things like a top 10 favorite songs list, things that are in order based on your top 10s. Then you might also have spatial order. That's things like a grocery market list based on the aisles, right? The produce aisles, all the stuff you would need in the produce aisle, all the stuff you need in the meat, okay? I'm not quite sure that this is a sequence because we would see words like first, next, then, finally, before, after. Not so much then. You might see the word after, but that's just transition. You might see transition words in everything, but nothing that's a signal word that says, oh yeah, this is sequence. This is following a certain sequence. So looking here, let's answer this question. In order to illustrate the science of roller coasters, the writer uses which method of organization? Is it A, cause and effect, B, order of importance, C, compare contrast, or D, problem and solution? Can't be order of importance because order of importance, remember, are lists, almost things that are like your top 10 favorite things to do on the weekend in order. So this is not a list. So I'm going to say no, it is not order of importance. Then is it compare contrast? No, we're not comparing two things. You would see words like similarities, differences. I don't see that. It's not compare contrast. Then you have problem solution. I don't see a problem. There's no issue here. I don't see a solution. So it has to be cause and effect because of the relationships between science and roller coasters, right? So a lot of times they're talking about the cause and effects of kinetic energy and potential energy. Okay, so you're going to find now all the details here. Please let me know if you have any questions about this video.